Welcome to the project demonstration of battery management system with ThinkSpeak, and where we are going to calculate the state of charging and state of health. So totally around 6 parameters will be continuously uploaded to the ThinkSpeak cloud platform, and the same details will be displayed on this 16:2 LCD screen. So here the details are like battery pack 1 voltage, battery pack 2 voltage, and battery pack 3 voltage, along with the temperature of these battery packs also. That will be measured by this temperature sensor, and after some time of duration, the system will calculate the state of charging and state of health. So this will be uploaded to the ThinkSpeak cloud platform directly with help of ESP8266 Wi-Fi module. So these are the BMS. Just click on this one. After logging to the ThinkSpeak channel, just click on that. There you get the data. So these are the data which we have uploaded while we are testing that. So in that, the BP1 is a battery pack 1 voltage, and battery pack 2 voltage, and battery pack 3, and the temperature along with SOC and SOH values. Total 6 parameters continuously uploading to the ThinkSpeak cloud platform. So here, if you want to get the fresh data and if you want to erase the old data, then we need to go to data import export, download that. So before erasing that, better to download the previous data, and it will be open in Excel sheet format. Right. So it consists of, first column is date and time, and second column number of entries till now we have collected, and the third column is battery 1, battery 2, battery 3, along with temperature and SOC and SOH values. So these are the parameters continuously we are going to receive from the Excel sheet. We can access that. Once you downloaded that, to erase, go to channel settings, and in that only do clear channel. Don't do any other options. Don't do like delete channel, only clear channel. Then go to private view to access the live data. There you see the old data got erased. And coming to the interfacing connections, so we are providing 230 volts AC input to this transformer, so which will step down the 230 volts AC to 12 volts of AC, and that is the input to this regulated power supply board. On this one, we have the 3 stages. One is rectification to convert the AC to pulsating DC, and the next filtration to remove the pulses and to make that pulsating DC to smooth DC, and that is a 12 volts smooth DC. That is the operating voltage as well as for the charging voltage of our batteries. So that 12 volts DC is input to this battery pack through these 3 electromagnetic relays, and negative was directly given to this battery packs, and positive was given to this each and every battery pack to the each and every relay here. And next, the operating voltage of our microcontroller is 5 volts. So in order to regulate that 12 volts DC to 5 volts DC, we are making use of this 7805 regulator, which will take 12 volts DC inputs and provide us a 5 volts DC output. So once we provide that to this microcontroller, it start reading input from the sensors. So the main sensors are like, first voltage sensors, 3 voltage sensors for the 3 battery packs. So each voltage sensor consists of 10:1 potential divider ratio, nothing but 10 kilo ohm and 1 kilo ohm. So the purpose of this potential divider is, we are providing 12 volts DC input to the controller to measure the voltage of this battery pack. So this is a 12 volt is greater than the 5 volt. So controller can measure up to maximum 5 volts. So make that 12 volts below the 5 volts. We are dividing that with 10:1 potential divider ratio. Whenever we are providing 12 volts DC input to this potential divider, the output of this potential divider is 1.2 volts, means 12 volts is the input, 1.2 is the output. Inside the microcontroller, we multiply with 10, as we know the potential divider ratio is 10:1. So like that, A0, A1, A2 pins is interfaced to the microcontroller as a voltage sensors, and A3 pin for this temperature sensor. And the next, relays based on the voltage input. Whenever the voltage level is below 10 volts, then as indication of low battery voltage of respect to battery pack, then the relay will get switched on. That will be done from the microcontroller at the pin number C5, C6, C7. And whenever the temperature crosses the 43 degrees centigrade, system will provide us the audible alerts through this buzzer, which was connected at C4. And the continuously data will be uploaded to the ThinkSpeak with help of this ESP8266 Wi-Fi module, which was connected at B0, B1, and the so-called status continuously monitoring on the LCD screen, that is connected at pin number B2 to B7. So these are the main input and output modules in our projects, along with workflow. So let us see demonstration. Before on the gate, just on the hotspot in your phone, as we need to provide the data along with hotspot to the kit to upload the data to ThinkSpeak. So go to hotspot settings, configure the hotspot to project 6044 without any space, without any capital letter, and password should be 123456789 and band should be 2.4 gigahertz. After enabling the hotspots, on the data and now on the power supply to the kits. So welcome message will be displayed initially, then after the system will monitor the voltage of this battery pack. As the battery pack 3 voltage is less than the 10 volts, that's why it's getting switched on to charge the battery pack 3. So this is a battery pack 3. And we can see one device is connected into your mobile phone, that's the ESP device. And now just log into the ThinkSpeak and wait for the data to be uploaded into this. So if the relay is continuously on and off, just to make the battery fully charged, just disconnect the respective battery pack from this voltage sensor. So then the system will making the battery pack 3 has low voltage. It will keep on charging. You can just leave it for 10 minutes. Then automatically the respective battery pack will become under full charge. So, right, we got the new data on the ThinkSpeak. So when we click on this, we can see the date and time along with value. Right. Okay. So if I increase the temperature, so when the temperature crosses the 43 degrees centigrade, so go to the audible alerts, and when the temperature comes down normal, buzzer will be off. Right, so it's a continuous process. Now let us connect this one. Right, so as of now you can see the battery pack 3 is little how charged. Right.